folks, Captain America here, and I'll be teaching you about the rate of a reaction. Now, I'm no scientist myself, but Ashley Grimmer, who just performed the elephant toothpaste experiment for you, is, and she told me that there are 4 major factors that affect the rate of a reaction.
These are temperature, surface area, the presence of a catalyst, and concentration.
Now, to understand why these affect the rate of a reaction, we must first consider what actually happens in a reaction.
According to collision theory, in order for any reaction to take place, the reactants must first collide with one another, and with enough energy to break the bonds between them and transfer electrons.
The minimum kinetic energy required for them to be able to do this
is known as the activation energy. Once the reactants reach the activation energy, they will form the activated complex, a transitional state between the reactants and products which exhibits bonding properties of both the products and the reactants.
With enough energy, the reaction will go to completion. Otherwise, the activated complex will revert back to reactants. The activation energy of a reaction is often quite high, so a lot of energy may be required for a reaction to occur. Collision theory also states that a collision must occur with the correct
orientation. For a reaction to occur, the particles must collide at the correct place, known as the reactive site. If hydrogen chloride collides with ethene, where its hydrogen meets the ethene's double bond, they will react to form chloroethane, provided that they collide with enough energy. If they collide in a different position or without enough energy, they will simply bounce off one another and no reaction will take place.
So, with the number of successful collisions determining the rate of reaction, any factor that affects the number of collisions affects the rate of a reaction. Now, back to those 4 factors.
Temperature, being the average kinetic energy of the particles, determines the energy the particles contain. The higher the temperature, the greater the average kinetic energy of the particles, the more particles add to above the activation energy, and the greater the number of successful collisions. This is evident in the results for the clock reaction. Potassium iodide and bisulfate were mixed together, but the temperature of the solution was altered. The time it took for the reaction to go to completion, on average, decreased with an increase in temperature. The same can be said for experiment 5, in which hydrochloric acid was added to a sodium thiosulfite solution and heated to various temperatures. Notice that the change in the rate is non-linear, but more closely resembles a quadratic, as the particle's velocity is equal to its kinetic energy squared, and so the increase in collisions will follow a similar pattern. The surface area of a substance determines the amount of particles exposed to other species with which they may react. Increasing the surface area increases the number of particles open to collisions with different species, and thus increases the number of successful collisions. Experiment 3 reacted marble with hydrochloric acid to produce hydrogen gas that then inflated a balloon. One of the trials used marbled chips, while the other used ground-up marble. The marble powder, having a greater surface area than the chips, resulted in a faster reaction rate. In experiment 2, a layer of lead-2 nitrate crystals was poured into a layer of sodium iodide crystals. This only produced a thin stripe of products, where the crystals came into contact and could thus react. However, shaking the test tube, thereby increasing the surface area shared by the different species, turned the entire mixture yellow. The presence of a catalyst also affects the rate of a reaction. Catalysts do not affect the reaction as a whole, but instead alter the activation energy. Positive catalysts will reduce the activation energy needed to complete a reaction, thereby reducing the time it takes to reach its energy level and complete the reaction, hence increasing the reaction rate. Negative catalysts or inhibitors increase the activation energy, thus lowering the rate of a reaction. When pink cobalt-2 ions were added to a hydrogen peroxide and sodium tartrate solution, it acted as a positive catalyst, greatly increasing the rate of reaction. The solution proceeded through the reaction within minutes, whereas the solution without the catalyst had to be left overnight to complete. Same goes for zinc in a hydrochloric acid solution in experiment 7, where the reaction proceeded faster with the catalyst copper sulfate than without. And finally, concentration. Concentration determines the number of particles in a specific volume. Increasing the concentration of a species will increase the number of particles. More particles means greater chance of a collision, thus increasing the number of successful collisions possible. Experiment 4 reacted magnesium with hydrogen chloride, but the concentration of hydrogen chloride varied. Consequently, the solution with the greatest acid concentration reacted the fastest.
So those are the 4 major factors that affect the rate of a reaction. The rate of a particular reaction under specific conditions can be predicted using rate law equations and Arrhenius' rate constant equation. That's enough science for me. Until next time, Captain America out!